Hello, my name is Carx82 and welcome to something a little different. I'm actually going to do a little video on how Gregtech power works. Now, I see a lot of people getting confused as why their machines are getting not enough power issues. So I thought I would just do kind of a quick explanation of how the Gregtech power works in Gregtech. Now, to get started, we need a generator. So I'm just going to go with a basic diesel generator. Put that down. And the white dot is where the power comes out. Now, diesel generator needs some fuel, so I'm going to do just do cetane boosted diesel in a drum, and I'm also going to need a way to get it. So let's get that hopper. And we'll just fill that up a little bit with diesel. Alright, so now the diesel generator has cetane boosted diesel in it, and it is producing power. Now it is producing, depending on the tier, 32 EU per tick is what the basic one does. And if you go up the different tiers, 128, 512, and so on and so forth. Now if you put a machine down, let's just put a furnace down. Right next to it, and put something in. Let's do cobble. It'll take the fuel that you're doing, produce 32 EU per tick, and smelt the cobble. Now that's all fine and dandy. You have one generator, one machine, but that's not going to do very much in Gregtech. So what we want is multiple machines. Now, for that, we are going to need cables. So let's put a few down here. And we can put some tin cables down. Now, if we look at the different cabling in here, we'll just do LV. So there's a whole bunch of different cables. So there's cobalt, red alloy, lead, zinc. There's a whole bunch for every single tier. And if we look at the different voltages, like cobalt is 32, tin is 32 also. But if we look at the amperage and the loss per block, this is what differs between the different materials. So tin, a 1 times tin cable can hold 1 amp, and it loses 1 per block. Now what an amp is how many machines are outputting power into the cables. So we have one machine, it's outputting 1 tin, or one packet of 32 E per tick. So I can put this down. It's transferring 32 EU per tick into the furnace that we have here, and it should be running. Yep, there it goes. It's staying full of power. And we could actually run more down here. And we could keep putting this. Let's get some more cobble. All down here, and they're all running off the one cable. And the reason they can do that is because the furnace, I don't know if there's actually, if you can see the recipe for that. Yeah, it doesn't actually show up on the smelting recipe. But usually smelting uses about 8 EU per tick, I think it is. So it's not a lot. Now when we start getting into problems is when we have higher producing machines, and one of those is the fluid extractor. That usually causes the most problems. So if we look at this fluid extractor, we'll place that down, connect it with power. It's filling up with the EU per tick here, but we need to, if we look at the different recipes, there's lots of them. They all use 32 EU per tick, which is the max. Like LV, well, these use 4 EU per tick, but the majority of them use 32 EU per tick, or 128, which is the MV voltage. So in order to extract that, say we use, let's grab some zinc or iron, I guess. Grab a stack of iron here. And if we do a use 32 EU per tick for 4 seconds, and it'll extract the iron. Now if we put this in here, put this all in here, and if we look at the energy at the top, it's actually going down. Which means this machine is actually not getting enough power. It's not getting the 32 EU per tick that it requires. So it'll tick down lower and lower, and once it reaches the very bottom of the buffer, it'll pop up with the red exclamation point and it slows down. It's not a super difficult recipe, but you can see it buffering a little bit here. It's struggling to melt all this down. And the reason for this is loss in the cables. Now if you look at the recipe again, it requires 32 EU per tick. And this is outputting 32 EU per tick, but because of the loss in the cable, it's only going to receive 30 EU per tick. So when the power comes out of the machine, it reduces it down to 1. So this one will be 31 EU per tick. This will be 30 EU per tick. And we can test that by putting another one here. And putting some iron in here and seeing what happens there. And again, it is not getting enough power because it's only getting 31 EU per tick. Now if I take this out and let those finish up this process, it'll fill back up again. So now they're both about 1,000. I put iron in both of these relatively quickly. We'll see that one of these runs out of power much quicker than the other one. And the reason for that is this one's still running. This one has almost no power. This can't run at all. This is because they're both pulling or both requesting from the power system 32 UE per tick. And we're only producing 32 UE per tick, so it is going from here straight into this machine, and there's no more EU per tick that it can use. So this one doesn't get any. Now if we look at the furnace again, I can put 4. And let's see, let's just put 16 and 16. And if we look, these are all actually running off one wire, off one generator. It is because these recipes are not requiring 32 UE per tick. It'd probably be easier if I do, let's say, like the wire mill. If we do this. Now they're all running, no problem. And the iron recipe for the wire mill here, let's see if we can find it, there it is, only uses 8 EU per tick. So these three machines are only pulling 24 EU per tick, and that's why these 3 machines can run off 1 generator. Now if we go back to the fluid extractor again, since this needs 32 EU per tick and it loses 1 immediately from coming out of the generator, if we put it right next to it, put some iron in there, it is getting enough power, so it can run this constantly. So when you're setting up machines and you're seeing the red exclamation point, it means it's not getting enough EU per tick from the source of the power. Now, we could, if you wanted to, set up a generator for every single fluid extractor. So we could set up a diesel, and run a bunch. If we wanted to, we could do that. In order to do that, we grab another diesel generator. Put that down there. And we need some more. Need to put some more fuel in this. Alright, that should be enough. Alright, so now these are running. There's 2 generators on this line. We have a bunch of different machines on this line. And let's say we want to put down cable. So I can put this one down like normal. Now if I add a second generator on here, that's going to be putting out 2 amps. So 1 amp is from this generator, 1 amp is from this generator. And these cables can only hold 1. So if I put this down, the cable should burn. And there it goes. So definitely don't want that happening. The way to solve that is to use better wiring. So if we do the tin cable again, let's go up to the 4. So this can carry 4 amps worth of power. So if I put this down, like normal, and there we go. The wiring is not burning up, because there's 2 amps going through it, and it can actually handle 4. Now let's grab some more iron. And let's throw some iron in here. Now this is actually getting enough power, even though it's 1 away from this, because there's 2 generators on this line. So it's asking for an amp, it's asking for its power, and then when there's some left over, it's going to get it from another. You can accept up to 2 amps per machine, I believe. So since there's 2 machines on here outputting, or 2 generators outputting power on here, this can actually get enough power. Now this one cannot, because it's too far from the source here. Due to this machine running, and it's pulling power from both of these machines, it's not leaving enough for this to run. It's getting a bit, as you can see it's trying, but it's not getting enough. Now as soon as this one turns off, this one can run again. And there is enough power on this line. So it should be, it'd be like 31, 31, 30, 29, but since there's another generator on here, it can successfully run. Now that is one way to do it. If you want to make a whole bunch of generators, the problem with that is you're going to have to make a lot of fuel or steam or charcoal, whatever you want to do to get those to run. Now another option, let me just get rid of some of this stuff. Another option would be to put battery buffers. Now battery buffers have different slots. They have 1, 4, 9, and 16. And that just decides how many amps you want to, or how much storage you want to put in the battery buffer, and how much output you want. So if I choose this 16 slot, put it on there on the end of the generator, have the generator going directly into this battery slot. I have 16 slots here that I can put batteries in. Now each tier has different batteries, so tier 1, tier 2, tier 3, and so on and so forth, all the way up to tier 8. So the LV battery buffer, we need the small batteries, tier 1. Now there's 3 different types. You can do 50,000 EU per tick, or EU with sodium, 100,000 with lithium, or 75,000 with cadmium. I'm just going to grab a bunch of these and put them in here. So now we have 16 batteries in there, able to accept power. So here we go. The generator is taking the fuel, creating 32 EU per tick, and inserting it directly into the battery buffer. Now these will fill up, and if you look at the tooltip at the top, it can hold 1.6 million EU per tick. 6 million EU, sorry. Now batteries can accept 2 amps worth of power. So I could also, if I wanted, put another diesel generator. And actually, let's put this here. With the wrench to turn, if you look at the face of the machine, the center block is that side. The left and the right are to left and right. You just click on those, up, down, and then the ones in the corners are the back. Let's turn that off. So I want to face it towards the diesel generator, so I'm going to shift click and turn it to face that. And let's put this down here. And there we go. So that's pulling in fuel. Now this is charging at double the rates. So it's accepting 2 packets of 32 EU per tick and filling up these batteries. And this will just continue to go along and fill up every battery. Once it's full, it'll move on to the next battery. And we'll see that in just a second. There we go. So now it's moving on to the second battery. It's going to do that all in a row. If I had 4 diesel generators on here, it would do more than 1 battery at once. But since I only have 2, it's going to go one at a time. Now what this battery buffer does, I'm going to break this, is actually output multiple packets of EU per tick. Now each battery can output 1 amp. So I could actually have multiple machines running off one battery buffer, that is. But to do that, I need to use different cabling. Now this has 16 batteries in it, so I'm going to have to use the 16 amp tin cable. If I put anything smaller than that, this cable will burn up. Because this has 16 batteries in here, this is outputting 16 amps. And once again, good. Test this with the basic fluid extractor. Put that down. It's getting the power. The buffer is going up. And we'll give it some iron. And once again, the power is going down. Slowly, but it's going down. And that is because this is outputting. It's pulling. It's asking for power. It's asking for 32 EU per tick. Whatever the recipe calls for. So it's asking for this amount, and it's not getting it because this is outputting 32 EU per tick, but it's actually losing 1 on the way. So this is only 31. And obviously it finished the task, so it filled back up again. If I put this here, that will be getting enough EU per tick with this. Now what this does, the different machines, some use a lot of power with their recipes and some use less. The wire mill, as we saw, only uses 8 EU per tick. So I could actually put this way down here. So if this is getting 31, 30, 29, 28, 27, 26, and so on and so forth, I could put this all the way down here. Connect that, and this should get enough power to run, and it is. The buffer, as you can see up at the top, is not going down. It is using these things, and everything is fine and dandy, and it's going to be pulling from one of these batteries. Now, since I am only asking for 8 EU per tick, and these are generating 32 each, I'm still going up in the battery buffer. Now I could also do if I want, have a whole bunch of machines here, and let's just grab a whole bunch of iron here. And I could be running all these machines if I wanted. And they're all getting enough power because now I have a bunch of different batteries in here. Now, the batteries that don't have any power in them do not output power. But since these are using in small enough packets, they're only using 8. It's going to be okay with the 4 batteries that are using power. Now, what that means for the certain machines that use quite a lot, I believe the electrolyzer here, this is another high usage machine. It uses 30 EU per tick. So it's the same as the fluid extractor in that regard, but since it uses 30 EU per tick, let's put some salt in it. Oh, that's saltpeter. Alright, so it's asking for 30 EU per tick for this recipe. It's getting 31, 30, then it's going in here, it's getting enough power. If I move it one more down and put this in, now is only getting 31, 30, 29. It's not getting enough to run the recipe, and it is losing power. Now the solution for this is either, what I usually do in my worlds, is put the EU intensive machines, which are the fluid extractor, the electrolyzer, I believe the forming press is another one. Let's see, where are they? Yeah, so if we're making the circuits, this is also using 32 EU per tick. So this needs to be right next to this, but even one cable in between the battery buffer and these machines that require 32 EU per tick is not going to be enough. Now, one of the solutions we can do, let's stick with the fluid extractor here, is we can actually put a battery in this little slot right here. And it will keep the buffer full, but drain battery power from this battery. But it will complete the task, even though it's not getting enough power. But as soon as you pull out the battery, it's going to start losing. Obviously, if the battery is empty, it's not going to do anything. And they do not charge in these. So you can either, like I said, put the machines close to the battery buffer so they get enough EU per tick. Or another solution would be to place a second battery buffer. Let's just do a 1-slot battery buffer this time. There we go. Actually, let's go farther down the line. Let's put it down, how about right here? We'll put this battery in here. And then we will put the fluid extractor here. Give it some energy. Now, since this is way down from the battery buffer over here, but it's still getting enough power over here because it's drawing from this battery. Now, the one problem with doing it this way is the battery buffer is also requesting, it's using 32 EU per tick, and it's asking for power. But because of the loss in the cables, this battery is actually not getting enough power. So it is, you can't run it constantly if you want to do it that way. But if you want to put a bunch of batteries in, these will fill up. These will use the like when the fluid extractor is running for whatever you need it to run. Like if you have a stack of iron you want to melt down, it'll use up the buffer. But since you have enough batteries in here, once it is stopped running, the batteries will all just start filling up. Now the reason these are filling up multiple ones is because there's multiple batteries over here outputting power. So this is capable, when these are all full, outputting 16 amps of power down this line. So that is the reason a bunch of these batteries are all filling up. Now one last thing before I finish is transformers. And I know there's a lot of questions about transformers. Usually these transfer down. So let's do, how about we do a medium one? Now this has the outputs, the smaller circle. This is the inputs. So the bigger circle is where the higher input power is going to be. If we look at this, the voltage in is 128 and the voltage out is 32. Now if you remember, these machines only can accept low voltage, 32 EU per tick. If we put a medium batteries buffer on this line, where is it? Medium battery buffer, and then we will point this is the output. It's a bit hard to tell on this one. You can tell because It's darker on that. So let's face it towards this one. This has medium batteries, so let's just do one of these in here. Obviously we're not getting power in this one. Diesel. I will add that, face it towards that, and then we can add fuel. And that will fill up the medium voltage battery. Now if we see this is putting 32 EU per tick in this medium battery, but this is outputting 128 EU per tick. And the reason it's outputting that is it's trying to fill these batteries, as we can see. So if I just break that, this will start filling up with EU per tick. Now what this does is the transformer takes the medium voltage and breaks it down into 4 amps. So 128 come out of this battery. We look at the batteries, medium. Actually, it does not say on that one, but the medium voltage, let's do copper cables, is 128 EU per tick. So it's outputting that. It's breaking it down into 4 packets, actually, and sending it down these lines, whichever way it needs to go. It can't go in there because the output is on the side, but it can send it over to here. So if I do break that, it's sending the power from here down the line, transforming it down to LV, and it's sending it to this wire mill, and the wire mill can run. So that is a couple ways you can do the power system. I find it easier to do battery buffers, store a bunch of power using 1 or 2 generators, and then using it when I need it on demand. For more intensive recipes, if I need to run my fluid extractor for a long time, I'm not producing enough power to run a bunch of machines, but since I have enough stored up, they will continue to run, and then when I'm not running everything, the buffers will fill up. And you can even, if you want, stop that. I can fill the there we go, put the batteries in there. And these will actually, this will fill up this battery, output it into this battery buffer and fill up this battery buffer. When this is full, then this will fill up, and so on and so forth. And you can do LV, MV into LV, and then you could have an HV producing battery buffers and sending it to an MV, which will fill the MV batteries, which will send it down to the LV, and so on and so forth. Now what you want is to be sending, the longer the distance you're running, the better cables you want to be sending it through. So say silver, it only loses 1 per block, but it carries 512. So if you run that over long distances, it's still going to get, if you run it through 20 blocks, it's still going to get 492 EU when it gets to the other end, and then you can transform it down. If you ran 20 of these cables, it would only get 12 EU per tick by the time I got to the end of a row of 20. Or even less, because it actually loses 1 on the output. But that is just a little bit of an explanation of how Gregtech power works, amps, and voltages. The moral of the story is put the high energy machines closer to the battery buffers, especially with LV tier, because the loss, one EU per tick on a 32 EU per tick line is much higher than one on a 512 or a 2048 EU per tick. But hopefully that'll be a little bit of an explanation and help if you are a little confused on how the Gregtech power works. And before I finish, what you don't want to do is put the medium voltage on the low voltage line. So if we do that and give it some power, let's throw the diesel generator back. Actually, let's do the medium voltage generator. And let's get some fuel. And it's going to cause some fires because that is trying to transfer 128 EU per tick into the batteries. And the reason it didn't go this way is because there wasn't any power flowing in that way because there was nothing requesting it over here. Now that isn't too bad, but what is bad is if you put it into our trusty fluid extractor here. You get an explosion. So yeah, never connect the medium voltage or a higher tier to the lower lines. Anyway, that's going to be it. So thanks for watching and have a good one.